Hello everyone and welcome back to another episode of the Hidden Quantum Champions. Today we are going to look at a company called Quantropi that is using entropy for quantum encryption. And if you are interested in this sector of the quantum technology stack, then make sure to stay tuned for today's video. Also, as always, get yourself something to drink and get yourself comfortable as we are diving deeper into Quantropi. But before we do that, let's maybe quickly talk about this idea of cryptography and why quantum plays a role here. So if you're looking at today's cryptography, there's this great invention of, let's say, the prime number factorization-based cryptography. So what does it mean? It means that we are using a property of the numbers called the prime numbers. And the prime numbers are numbers that only can be divided either by 1 or by themselves. So let's think about a couple of numbers for a second. If you're thinking about maybe, let's say 4. 4 is divided by 4, of course. 4 divided by 4 is 1. Is divided by 1, that's also true. But you can also divide it by 2. So 4 is not a prime number. If you think about 5 as an example, 5 can only be divided into integers by 1 and by itself, so by 5. 6, however, can be divided by 2, by 3, and so on. So these are prime numbers. And now with those and the prime numbers themselves, they are not, let's say, equally distributed throughout the numbers. So it's actually hard to predict if a specific number is a prime number. And this kind of randomness that underlies the property of prime numbers is being used to basically create cryptography. Because now if you take two very big prime numbers that you know and you multiply them by each other, you can get a very, very large number. And you cannot easily say what are the two factors that basically make up this number as integers. And this is an asymmetric problem, right? Because multiplying those is easy, but then on the other side, factorizing those is very difficult. And it's not only difficult for us, it's also difficult for today's computers. And that's basically what underlies today's cryptography scheme. Now, the issue with that is that with quantum computers, there is something called the Shor algorithm, named after its inventor, Peter Shor, which basically can be used to extract the prime numbers, to do a prime factorization. For that, you do a quantum Fourier transformation. And then basically the quantum computer gives you a signal back which tells you what are the prime numbers. And that can happen at a much faster speed than traditionally with today's computers. So the quantum computer would break today's encryption idea or encryption mechanism. And that makes basically the whole story very complicated, because now you cannot just anymore say, I take two big numbers, I multiply them, and they basically make sure that I have a safe way to encrypt everything, because it will take today's computers longer than the existence of the universe to actually, let's say, to pull out those factors again and thereby decrypting the message, or let's say, to brute force out the information. But now with a quantum computer, that can happen much faster. And this problem has been discovered quite early, even before, I guess, there were like quantum computers that could do something that is close to meaningful, which is the time that we are in today. So Peter Shor invented this algorithm quite a while ago, and for that it was kind of clear that if we are on a trajectory where quantum computers can actually start to scale, to actually do useful stuff, then this will become a topic. So now, let's say in the NISQ era, so noisy intermediate quantum systems era, we have computers that can run the first kind of algorithms, we do the first types of tests, and suddenly this whole topic becomes relevant. And with that, there's of course also people that have been thinking about it, and there are, let's say, roadmaps about that. For example, by American, let's say, national institutions that are thinking about, okay, how can we make sure that today's communication is encrypted in a way that is already safe for tomorrow if the quantum computers can ever, let's say, break the classical encryption scheme. And this is exactly where Quantropi comes in. How can you use today's ecosystem, today's what we have to make the communication safe also tomorrow. And now with that, let's dive a little bit into it. It says post-quantum security made true, with UE at the end. So today's capital UE at the end. Today's encryption and cryptographic keys will be no match for the Y2Q quantum threat. And I think that's the harvest now, decrypt later idea. Only Quantropi's QiSpace platform provides a true suite of lightweight quantum secure products to protect our data, IoT, connected devices, and communications. Y2Q meet true quantum security. Then we see that there is an announcement here that they will be at an exhibition in mid to end of May. I'm recording this beginning of May, so you can see that it's very much up to date still. And we see what time is it, Y2Q, so advances in quantum computing and recent breakthroughs using hybrid attack methods that incorporate AI and machine learning have drastically reduced the quantum capabilities required for Y2Q. The day bad actors will be in a position to break today's encryption. Y2Q could be 1 to 3 years away. That's the statement that they make here. Most vulnerable is the IoT space, and it's 13 billion, growing to 25 billion by 2030. Connected devices where compute power and memory space are at high premium, so weaker or no encryption is often deployed. And IoT, so this is the Internet of Things, it basically includes devices like your smart thermostat, like your connected fridge, like your vacuum cleaner robot, your smart TV, all of these devices that are not, let's say, per se computers, but that have been added with compute capabilities and hence also connectivity to the internet. So that's very important. These are connected devices that basically can connect both to the real world because they're devices and to the internet. And of course, you want to make sure that these are safe from malicious actors because you don't want anyone to kind of be able to remotely connect into your home, retrieve some private data, but then also possibly actuate things like, I don't know, you have a smart AC and suddenly it turns on even though you didn't trigger it, right? So that this can easily become a nightmare and you want to avoid that. But of course, usually the machines, the computers that are sitting within those smart devices, they're oftentimes very tiny. So sometimes we are only talking about microcontrollers, so they don't even run an operating system. Sometimes they have a bit more compute power and then you would have like a small CPU in there. But usually these are not very, let's say, strong compute devices, also because oftentimes they are battery driven or there's a battery component to them and they're supposed to drain very, very low amounts of energy because otherwise, your battery is not surviving for long. So there are more and more of those devices. We also see that, right? In our daily life, there are more smart devices that are connected to the internet. And now, basically, these are at risk because they have usually very strong very weak encryption or no encryption. And that is, of course, because if you add encryption, you basically make it more difficult for the small processor in there to actually do its work. So then you would have to increase the processor size and so on. So that is not easily something that you can do. So prepare for this threat with QiSpace, the only platform on the planet providing all three prerequisites for end-to-end quantum security, which is trust, uncertainty, and entropy. And that's what they call true, right? So TR like trust, U like uncertainty, and E like entropy. Fast, lightweight, resource efficient, and readily deployable encryption and entropy services that work seamlessly on today's internet. And so you have these three components, and they are, let's say, at the base for this whole encryption scheme. And I guess they will also later on explain why this is the case. So the QiSpace product families. So you have Mask, of course, with a Q at the end, which is ultra high performance novel PQC, post-quantum PQC, with the smallest public key and signature sizes and the fastest sign and verify of any NIST PQC candidate. Then QEEP with a Q at the beginning, quantum secure symmetric encryption, bridge the gap between classic and quantum systems up to 18 times faster than AES 256, and only available through QiSpace. And then secure, of course, with a Q as well, quantum entropy services, including synchronized quantum secure digital distribution, digital QKD, quantum key distribution over any existing network. Then, okay, there's something about quantum secure TLS with QiSpace. So digital signature and key exchange algorithms are at the heart of every TLS secured internet transaction, including web browsing, messaging, and email, to the tune of more than 1 trillion transactions daily. Only QiSpace upgrades all three cryptographic elements from asymmetric and symmetric encryption to strong random numbers to make every client a safer handshake quantum secure. With millions of digital transactions per second worldwide, true TLS powered by QiSpace has the potential to seamlessly integrate at every level of your data communications, email, HTTPS traffic, browsers, devices and networks with nothing but positive impacts on performance. So we have a software solution here that is very lightweight, that can be integrated easily into existing systems as of today, and that basically consists out of these three components here. With that, I think we can also quickly check out the products, which I guess are exactly these three that we've just seen. So let's open this very quick. So the QiSpace is basically the top level product, under which then these three lower level products are living. And the Y2Q countdown is on, so quantum computers are gaining ground and will soon pose an existential threat to all standard encryption methods. Unlike the Y2K millennium bug, there's no timetable or due date for Y2Q. All we know is coming much faster than anyone predicted. That's why bad actors around the world are already stealing and storing secrets, just waiting for quantum computing capacity to decrypt them. That's the idea of harvest now, decrypt later, right? It's why governments are mandating action and consulting providers are vying for position. Because like Y2K, Y2Q will affect every organization on the planet. Systematic preparation is urgent and non-optional. By beginning the transition towards post-quantum security today, enterprises can minimize the monetary and reputational risk associated with rampant data and security breaches. Quantropi is standing ready to protect the encryption you, your customers, and your stakeholders count on, thanks to the power and permanence of our flagship QiSpace software as a service platform. Uniquely capable of all three prerequisites for end-to-end quantum security, so trust, uncertainty, and entropy, only QiSpace provides true quantum security for your enterprise to thrive before, during, and after Y2Q. Migrating to QiSpace will ensure the continued growth and satisfaction of your valued customer relationships, so you can be confident in staying true to your business and brand promise and keep doing what you do best. So then you can try it out basically by contacting them. And here is what, let's say, the whole stack look like. So here on the lower level, you have your application level, so the software level. You have the user themselves, I guess, and you have the computer. And now every single one of them has a different, let's say, point to it, right? So you need to have you, as a user, you want to maybe do secure communications. As an IoT device, you need to be able to transmit secure data. And then on the application level, you need this quantum key. On top of that, you have the quantum entropy, which is generating these random numbers, right, that are required to basically do the encryption using entropy. True entropies or true random numbers. And then on top of that, you have the QiSpace cloud, which basically provisions all of this, right? So you have the QiSpace cloud, entropy generation, account provision, QiSpace enterprise, key distribution, system administration, and device management, and then powered by QiSpace applications, devices, end users, and IoT. Then again, you have these three products here, so mask, deep, and secure, and we will jump into those in a second. So let's do that. Let's start with mask, the asymmetric encryption. Very briefly, what is asymmetric encryption? So this is when you basically use some key to encrypt something, and then you basically share a public key that can be used to decrypt it. But you can make sure that only like somebody specific is able to decrypt this message. So technically, it is encrypted, and this is basically what the HTTPS is doing, right? So asymmetric encryption is basically everywhere today in our day-to-day world. Like, for example, on web services, when you log in somewhere and so on and so forth. So MASC is the cryptographic library which supports NIST-approved post-quantum cryptography algorithms for both key exchange and digital signatures. In addition, MASC includes a novel post-quantum cryptography algorithm developed by Quantropi, optimized to resource-constrained devices such as IoT with significant performance advances, such as small digital signature sizes compared to current NIST post-quantum cryptography candidates. So NIST is the American National Institute of, Standards, and they are posting, or they have been proposing some algorithms to protect basically against these quantum threats. And what Quantropi is saying here is they make a version of that basically uses a similar approach, but it is much more lightweight than the exact one that has been proposed here, right? So this enables customers the flexibility to choose the right algorithm for their need and the crypto agility to change algorithms as the security landscape evolves. The functions, so the two main functions of MASC, are the key exchange and digital signatures using a pair of public and private keys. So key exchange and digital signature. Digital signature you might know from your emails. So sometimes you want to sign off your email to basically show that it's really you who are sending this. And then key exchange is of course important when it comes to encrypting something. You need to make sure that you're exchanging the right key with the right person. Then we look at the QIP, so Quantum Secure Symmetric Encryption. QIP provides enhanced quantum secure symmetric encryption functionality powered by Quantropi's quantum permutation PAT QPP technology, which achieves a Shannon perfect secrecy. QIP extends the symmetric encryption key length well beyond the current 256-bit limit. It meets today's security needs and remains safe against future quantum computing attacks, all in a small, efficient, and high-performance package. Its small code footprint and low computing requirements make QIP the perfect solution to address cybersecurity limitations in resource-constrained environments such as IoT and OT devices. QIP is also high-performance benchmarked at up to 18 times faster than AES, which provides a significant advantage where low latency is a requirement, such as connected and autonomous vehicles. QIP can be combined with AES in a FIPS compliant approach to provide defense in depth with minimal impact to performance. Talk to quantum security expert today to learn more. So AES is an existing standard that is being used to encrypt as of today. And if you don't believe that, for example, these new algorithms are really actually safe, so it could be that, okay, up to today we've been using prime numbers. Now somebody comes up with a different scheme of doing that. Now, for example, I don't know, an elliptic curve. But now it might turn out that, okay, now there's an algorithm to actually crack the elliptic curve, because now that more computers are using that, there's more interest in actually being able to crack it, and somebody figures that out. So then you can combine today's existing with the next generation of encryption, and thereby you could potentially, I guess, make it more safe. So that's how I would understand that now. SEQUR, so secure. Start your quantum secure journey today with quantum entropy as a service, QeAS. So QiSpace secure provides scalable high performance quantum entropy as a service for the generation and secure distribution of quantum entropy or true random numbers to endpoints over existing network infrastructures. Its ease of deployment makes QiSpace secure a practical solution to enhance the security of current systems. Its unique differentiating features include multi-score quantum physical generation, quantum secure distribution, entropy sovereignty, and entropy expansion. And I'm not going to go into all of the details, but one of the customers that is being, or I guess one of the partners that has benchmarked this is the Deutsche Telekom, German telco provider. In their open QKD lab, the results confirmed secure sync SYNQK outperformed photonic QKD distribution rates over 250 times and can be used as a low-cost alternative or last-mile distribution solution for the QKD deployments. Okay. By the way, the company, and that's maybe also important, is based in Ottawa. So this is already like a Atlantic, cross-Atlantic collaboration here. There's also something here about the solutions. I will not go into all of these details for now. Maybe we can look at the partner solutions here. Well, let's see, what else do we have here? Yeah, maybe we can quickly check that part out as well. But I'm not sure if this is partners as in people trying out their technology or if this is a combination of what they do with somebody else. It's a strategic collaboration. So here you can see this is probably used in military and defense, law enforcement, security, emergency and disaster response. So this is, let's say, a combined use case. Let's quickly go into the technology part, but I'm not an expert in when it comes to that, as you've probably realized, so I'm not gonna go all the way deep into the technology. But just, on a very high level, let's go through that. Multivariant polynomial public key, MPPK. So post-quantum cryptographic systems are developed to be secure against both quantum and classical attacks. Multivariate cryptography is one of the major families of post-quantum cryptography, relying on well-studied NP-hard mathematical problems. So this idea of NP-hard problems is problems that are very difficult to compute on a classical computer, right? Quantropi has introduced its own novel post-quantum multivariant crypto system that establishes key exchange and digital signature mechanisms. MPPK offers comparable performance to current PQC algorithms and significantly smaller digital signature size of all NIST security levels. Quantum permutation pad, QPP, a novel quantum encryption algorithm that leverages quantum permutation gates for random number generation and symmetric encryption capabilities. QPP achieves perfect secrecy and is lightweight in its software implementation. In addition, it can be readily implemented in quantum computing environments due to the quantum nature of permutation operators. Having both classical and quantum implementations enables natively secure communication between quantum devices as well as hybrid environments consisting of quantum and classical devices. And then the third one is the coherent-based two-field quantum key distribution, so CTF-QKD, a novel signal modulation scheme leveraging existing coherent optical communications hardware and infrastructure to achieve physical layer quantum secure encryption. CTF-QKD allows for in-flight data encryption operating with no latency, is protocol agnostic, and protects all data being sent over the optical fiber. Currently, we have experimentally shown transmission rates of 200 gigabytes per second. CTF-QKD can operate in two configurations. In the round-trip configuration, a pre-shared secret is not required because one operator applies both the outbound signal encryption and inbound signal decryption. Another operator can send data by directly modulating it in the round-trip signal, and in the other way, in the one-way configuration, a pre-shared secret is required for operators at both transmitting and receiving ends, so they can symmetrically decrypt data. Okay, and with that, let's quickly check out about the company. As per usual, as we are moving to the end of the video. So ahead of the curve, the standard for quantum secure data communications, founded in Ottawa in 2018. Quantropi is bound to be the standard for quantum secure data communications, forever unbreakable no matter what, powered by quantum mechanics expressed as linear algebra. Our technology encrypts data in transit and data at rest, defending against today's threats and tomorrow's quantum-based attacks without requiring the processing power of a quantum computer. A 100% candidate innovator in the quantum communication space, Quantropi's QiSpace is the only end-to-end security software as a service platform with all three prerequisites for cryptographic integrity. So that's this true idea, right? And the QiSpace platform has these three components, right? The mask, which is important for trust, the QEEP for the uncertainty, and the secure for the entropy part. That's about the technology. Then we see some further information here. So not only does our technology empower users to achieve unconditional security, but it is also more cost-effective, scalable, and efficient than anything else out there. With our solution, enterprise leaders, government agencies, IT professionals, and anyone concerned about the data protection can be absolutely confident the information is truly future-proof, driven by a mission to ensure the protection of the truth and trust underpinning our global digital society. Quantropi is enabling enterprises to transition immediately to quantum-grade safety with zero invest in new hardware or infrastructure. Best of all, our unique platform solution works over today's internet, providing a simple evolutionary upgrade path to critically improved security. Our team is focused on delivering future-proof cybersecurity solutions to a wide range of industry sectors, including government, technology, finance, and telecommunications, to name but a few. And I mean, these are all the sectors that we also know that are, let's say, very critical in terms of data privacy or data safety. And that's also something that we have heard from, let's say, competitive solutions in the quantum encryption space. Here's a couple of awards that they have been winning, so long list, and I guess also publications that they made. Let's quickly check out the leadership team as well as probably the investors and advisors. So here's the let's say leadership team. So the Quantropi team brings a powerful combined background and skill set, deep in quantum technologies, cybersecurity, business strategy and entrepreneurship, finance, business development, and enterprise marketing. To learn more about opportunities and so on, join the team. So here you see basically the co-founder team, but you can also see that there is other functionalities in the company as well already, like VP Finance, and SVP Sales. So you don't only have, let's say, the tech people in there, and you have this very, let's say, nicely anonymized profile images available here as well. Let's quickly check out the investors that have invested into this company. So Quantropi, the solution to a $50 trillion problem. Investor presentation, for that you have to sign up. So yeah, it looks like we cannot see any of the investors here on the page. Okay, with that, I guess we are already at the end of today's video. I hope you found this interesting. So Quantropi is a provider for, let's say, quantum security solutions, so for quantum encryption, that already can run on today's infrastructure using a software platform that is called, I think it was, sorry, now I have to scroll down, QiSpace. The software platform is called QiSpace, and it has the 3 core components to it, which are mask, keep, and the secure part of it that makes sure that this trust idea is fulfilled. So that is, let's say, all software that can run on existing infrastructure as of today. It is a cloud solution, but it has also software components that can be deployed both for computers, as in like private browsing, messaging, and so on, and applications like finance applications that need to have an encrypted communication, but also IoT devices that are usually very slow or don't have so much compute power. And it can basically provide very slim algorithms that can run very efficiently on these tiny IoT devices. So that's Quantropi for today's video. I hope you liked it. If so, please make sure to give it a thumbs up. And if you listened all the way to the end, then maybe also consider subscribing to this YouTube channel to make sure to not miss out on the next video. Until then, bye bye.